In this session, we are going to learn about Seebeck effect, which was experimented by Seebeck. And when he experimented this, he found that when we combine two dissimilar metals forming two junctions, let us name it J1 and J2, and when you produce heat on one side and when you pull out heat on the other side, there's a difference in temperature produced. So, due to this temperature difference, a small amount of current is found to be flowing. So this was actually the result found by Seebeck. So it is basically when you combine two dissimilar metals and when there is a temperature difference, you find a current flowing through those two dissimilar metals. So Seebeck took iron and copper and he found the current with a galvanometer. So he also made a series called Thermoelectric Series. Before that, we'll learn about Thermo Emf. So Thermo Emf is basically the EMF produced due to this difference in temperature. So it was from bismuth to SB, and between these two, nickel, PD, platinum, copper and such metals were there. So it is basically when you take these two metals, it produces a very small thermo EMF, but when you take these two metals, it produces a very large EMF. Consider a graph where T is plotted on the x-axis and V is plotted on y-axis, where V and T are thermo EMF and temperature respectively. So we take theta C, which is the cold temperature, as origin, and if we keep on increase the temperature, the thermo EMF also increases, so it forms a curve like this, and at a particular temperature thermo EMF will be at maximum. So at the particular temperature where the thermo EMF is maximum is called the neutral temperature. And now if we keep on increasing the temperature, the thermo EMF will not increase, but it will decrease. So it will form a parabola, and at the point where the thermo EMF is 0 is called inversion temperature. We already know that the equation of a parabola is just y is equal to ax plus bx square. So to find the thermo EMF, we take y to be v and x to be theta. So it is just a theta plus b theta square. Here, by experimenting this, we find that a is equal to a constant alpha, which varies metal by metal, and b is equal to half beta, which is also a constant and which also varies with metals. So with these constants alpha and beta, we can find the thermo EMF when two dissimilar metals form a junction.